We will go now into the second part of this topic number 5. Okay, and this will be subtopic 5.2 about the Hardy-Weinberg law. We continue with the law of Hardy-Weinberg, okay, in which this particular law describes a population which is in genetic equilibrium. The law of Hardy-Weinberg states that the frequency of alleles and the frequency of genotypes, okay, will remain constant over the generation. Okay, in order for this law of Hardy-Weinberg to be applied, there will be these 5 assumptions. They say that the size of the population must be large. The second assumptions of Hardy-Weinberg will be random mating, in which all the individuals of the population can have equal chance to mate with each other. Assumptions number 3 will be no mutation. So in the population that we are focusing on, there should be no mutation occurring whatsoever. Why? Because if there is mutation, maka frekuensi allele akan berubah. Condition number 4, there must be no migration for the population, mean that the individuals of the population must not move out ataupun move into the population. Condition number 5, there must be no natural selection, okay, in the population, meaning that all the individuals, okay, of the population must have equal chance to survive. After talking about the law of Hardy-Weinberg and the 5 assumptions of Hardy-Weinberg, you just need to know about how to calculate the frequency of alleles and also the frequency of a genotype. Okay, and we assume that the population is in genetic equilibrium. Okay, why? Because in order to calculate this frequency of alleles and the frequency of genotypes, we need to we can use the Hardy-Weinberg equation. Okay, so this will be the equation. The equation will be p squared plus 2pq plus q squared equals to 1. Okay, so sila ingat ini. In which p squared, okay, p kecil kuasa 2 is referring to the frequency of genotype. Okay, the frequency of genotype. Just now, earlier we have talked about the frequency of allele. Now we are talking about the frequency of genotype. Semua ni adalah frequency of genotype. But for the p squared, it is referring to the frequency of genotype for the homozygous dominant individuals. Now what about this 2pq? What is the meaning of 2pq? 2pq will be referring to the frequency of genotype, but this time it will be for the heterozygous individuals. What is q squared over here? Okay, q squared will be referring to the frequency of genotype for the homozygous recessive individual. For example, small letter a genotype. Okay, and if we total up all this p squared, 2pq and q squared, you will get the value of 1. And so this will be the example of question that is very basic, in which it will be about a population of rats again. Suka sangat tikus topik ni. Population of rats, and we are focusing on a particular characteristic, and the characteristic will be about resistance toward a type of pesticide. This resistance can be controlled by a dominant allele, capital letter R. Okay, so information given here will be 64% of the rat population shows the resistance. So the first thing, how can you calculate the frequency of the allele capital R? Okay, and next you need to calculate the frequency of the genotypes. Homozygous dominant, capital R, heterozygous genotype, capital R, small r, and the homozygous recessive genotype, small r. We try to calculate the frequency of allele first. Okay, whenever we want to calculate, okay, normally we will start with the recessive group. Recessive group dulu. We will start with the homozygous recessive group. Okay, kenapa kita start dengan homozygous recessive punya individu? kerana kita tahu bahawa dia individu resesif ni dia cuma ada satu je genotype, iaitu R kecil. Kalau kita tengok kepada 64% ni, 64% will be the dominant individuals. Okay? But we are not sure sama ada mereka ni 64% ni adalah R besar ataupun R besar R kecil. Ada dua possibility. So kita fokus kepada yang resesif. Kerana yang resesif tu confirm dia punya genotype adalah R kecil confirm. So ingat tu, dia punya tip dia adalah start with the homozygous recessive genotype. Okay, which is Q2, which is 0.36. Okay, macam mana kita dapat 0.36 ini? Okay, kaedahnya adalah yang ni. Okay, 64% will be the dominant type. So 36% will be the recessive individuals, the recessive rats. So 36% we change into frequency. Percentage we change into frequency. How? 36 divide with 100 and you will get 0.36. Dah dapat? So Q2 sebenarnya adalah 36 bagi dengan 100 and you will get this value 0.36. Okay, clear semua? Okay, once you get the value of Q2, you continue with the value of Q. Okay, Q2 dah dapat dah 0.36. So we continue with the value of Q saja, which is the frequency of the recessive allele. Okay, R kecil. How? Just setkan dia. 0.36 kita punca kuasa 2, dapatlah 0.6. So this is the frequency of the recessive allele. Tapi kita nak the frequency of the dominant allele. Okay, don't worry. Once you get the value of the Q, then it will be easy because you just need to use this formula P plus Q equals to 1, in which the frequency of the dominant allele, capital letter R, is P. So P equals to 1 minus Q. Maka dapatlah 1 tolak 0.6 ni, dapatlah 0.4. So this is the answer for the frequency of capital R allele. Okay, now we continue with the B, in which you need to calculate the frequency of genotypes. Homozygous dominant, capital R, heterozygous, capital R, small r, and also the homozygous recessive, small r. So you just need to use, we just need to use the information that you have calculated already just now. Just now you have already got the value of P and you also got the value of Q. So kita gunakan dalam soalan B ini. Okay, in which we start with this one. The frequency of the homozygous dominant genotype, which is capital R, iaitu P2 sama dengan 0.4, okay, to the power of 2. Okay, kuasa 2 lah. So this is the frequency for the genotype capital R. And what about the heterozygous genotype? Senanglah. Just remember this formula of 2PQ. Okay, iaitu kita dah tahu dah bahawa 2PQ will be referring to the frequency of the heterozygous genotype. Okay, so 2 times P times Q and you will get the value of 0.48. And the same goes for the last part, in which again the value of Q2 will be referring to the frequency of the homozygous recessive genotype, which is 0.6 yang kita kira tadi dah, dan nilai Q 0.6, kuasa 2 dapatlah 0.36.